Okay, so here 2.7. So the last things I left from last time for 2.7 is the composition, is the example for composition. So here composition of functions. Okay, so example here. The example is, suppose f of x equal 2x minus 4 and g of x equal 3 minus x squared. First question is find f circle f of 2. Number 2 here, find g circle g of 3. Number 3 is find f of f circle g of 1. So here I gave you numbers is not a variable. It's not like last time a variables. It's number 2, 3, and 1. Who will do the first one? Who will do the first one? F circle f of 2. What is it? What is f circle f?
Minus 4.
What is the formula?
So it would be,
F circle f.
well, so first it would be 2 times 2 minus 4. And then that
Can
is
you give
in
me the formula
parentheses time.
for f circle f?
Okay, so it's 2 parentheses. Okay, so you're doing that way. Okay.
Okay, exactly. So you plug the 2 inside the function. What do you get?
So, well, you'd rather 2 and then in parentheses, what's in the x would be 2 times 2 minus 4.
Okay. This is f of this thing.
Yeah, that's the first function. So that's 0.
Then
and then it's
2 times 2 is 4. Yes, exactly, 0. And then
0 is plugged into where x is, so it's becomes 0 minus 4. Or
exactly.
2 times 0 minus 4.
4. They give you minus 4. Thank you so much. This is right. This is true. So for the second one, same idea. G circle G of 3. Give me the same things like here. G of 3. And this is give me, when you plug the 3 inside the G function, this function, I get 3G of 3 minus 3 square. And the 3 square is 9. So now I get G of 3 minus 9 is minus 6. And this is equal, G of minus 6, we plug the minus 6 inside the function G. 3 minus 36. Yeah, this is true, shy. Get minus 33. For the third one, F circle G of 1. What does that equal? f of 1. Now you plug the 1 inside the function g, then whatever you get here, you plug it inside the function f. Okay? So g of 1, you plug the 1 inside the function g here, 3 minus 1 square, and this is equal 3 minus 1, because the 1 square is 1. So I get now f of 3 minus 1 is 2. You plug the 2 inside the function f here, you get 2 times 2 minus 4. So you get 2 times 2 is 4, minus 4 is 0. So 4 minus 4 equal 0. Any questions so far for these things? Anyone has a question for this one?
For the second one.
What is the second question?
The g of g.
G of g, this one, right?
Yeah, that one. Yeah, when it says g of -6, when you plug it into the function, it doesn't turn positive, the -6.
Again, so g circle g of 3 equal g of 3. We plug the 3 inside the function here. So I get 3 minus 3 square. 3 square is -9.
Oh,
So
okay.
here like this I get. I'll show you again. So here, get 3 minus, open parentheses, 3 square.
Oh, okay.
And this is equal 3 minus 3 square is 9.
Yeah.
This thing's for 9. This thing's for 3 here. And the negative, keep it negative between them. Okay?
Oh, okay.
Okay. Any question? Any other questions? Same things for F, same things for F circle G. What's the other question for 2.7? Somebody asked me another question. I don't know what is it. Okay. So now let's go to the 2.8. It's one-to-one function. 1-to-1 function. And their inverse.
I'm sorry, Professor. Were you gonna show us an example of how to do the composition functions, like from a graph or a table?
Oh, from graphs? Oh, okay.
Yeah, like because in the homework it tells us to use it from a graph and also a table, but I don't know how to do that.
Okay, let's give it. So suppose, so the example now, suppose I have this graphs. The function f. So I have two graphs. The first one is look like this. You see the web sign question exactly.
Yeah, because on the web sign it's like a, one of them looks like a check mark, another one looks like a curve going up and then down.
Yes, I will open the website and check the question. Yeah, like this. Yeah, check mark and so. Okay. First one from 0 and goes up like this. And the second function is by blue color. For example, was like this. I'm not going to use exactly the same numbers, but I'm going to give you the idea.
Oh, okay.
So here is 0. Here's maybe like suppose 4. Here's suppose maybe like around 7. This here is like 5. This is y-axis. This is x-axis. The question is find g. The function, the blue one is the g function, and the red one is the f function. So the question is find if the value is like 4. G of f of 4. This is my question. So first things here, we have to look for the value 4 in the f function. The value 4 in the f function, this is 4. The value, the y value for the f function is this here, this point. So you have to find the y value for this one. It is here. Suppose this number here, for example, minus 3. So g of f of 4, you go to the number 4. This is number 4. You find the value, the y value for the function f of 4. So you go down like this. It's intersect with the curve at this point, and you find the y value. The y value is minus 3. This is the y value. You put it instead of the f of 4. So this equal g of minus 3. Now you go to the minus 3 in the Cartesian plane. Suppose the minus 3 is like around here. And you find the g value for this one. I mean like the y value when the point intersect the curve. Like that, it's minus 3. So you go up to find just the y value for the g, intersect the g function at this point. So suppose the y value will be like around this point here. This point, make it as 2. So the answer is equal to. Get the idea? What does that mean? Again, let me explain it again. So I have two functions, the red one, the blue one. The question is find g of f of 4. You go to the 4, you find the y value for the function f. So you go down, you find the y value. The y value is minus 3. You plug it instead of this one. So I get now g of minus 3. You go to the minus 3, you found the y value for the g function, the blue function. The y value means the y in the y-axis. So at -3, it shows here the y value for the g function is -2 or 2, I mean. So the answer is 2.
Okay, and what
It
if it
makes
was
sense?
like a, yeah, what if it was
Okay.
a question like f of g or f of f, like using
F
the
of
same,
f,
yeah, using the
the
same
same
graph.
function. You're using the same graph, the red one or the
Yeah.
blue one, whatever. Understand? It's good. So
Yeah,
for
so
example,
for f of f,
like f of for example 7. So this is number 1, this is number 2. f of 7. You go to the 7, you find it where is the y value for the f function. So the y value for the f function is 0. At 7 here, it shows 0. So this is mean f of 0. Then you go again to the f function and you find the value at 0. So at 0 here, the f function, the y value, it's 0 again. So the answer is 0.
oh, okay. So
Makes
the
sense?
first example is g of f, right?
Yeah,
The
g
first one?
of f of 4. So the first one, we use it, the 4 for the f function, then you use it for the g function, the blue one.
Okay,
For
so
the
the first
second
one,
one, we're using only the red function,
oh,
the
okay.
red function for the second one. Okay.
How would you do
Okay.
the chart?
Which one?
Oh, because on the homework there's another example, and it says use the table to evaluate the expression, and it's just like a chart with values, and we have to do the same.
Okay. Okay, let me give you the example. So the example now, suppose I have here example. I have x and f of x and g of x, and I'm going to give you different values like 1, 3, 5, 7. At 1, the value for f is give me like 10. I mean not 10. Let me using the same values because no, not 10. I'm going to use smaller number like 7. Here like 5. Here like 1. Here like 3. At 5 is 7 again. Here is 1, 5. Here is 5. Here's I'm going to use f of 5 is 3. F of 7 is 5. Here f of 1, g of 1 is 5, 3. Here I'm going to use 7 and 1. So the question is find f of g of 3. Okay, for these things, first of all, you go to the number 3. This is number 3. You find the value for g at 3. The value for g, the g function at 3, it shows here 3. So now the first step, you get f of 3. Now you go to the 3 again, you found the f function for the 3. This is 3 again, the value is 1. So this is the answer. Let me give you another one, f of g of 1. Again, you go to the 1, you find the g value for the 1. The g value for the 1 is 5. So f of 5. Now you get the 5, you go to the 5, you find the f function for the 5. It shows here 3. Makes sense? What's the idea?
Yeah, and if it's G of F, it's the opposite, right?
In the opposite. So G, for example, on an example, G of F of 3. I'm not going to use 3, 7. Same thing. So you go to the 7, you find the F value for the 7 is 5. So G of 5. Now you go to the 5, you find the G value for the 5, it's 7. So the answer is 7.
Oh, okay. And
This
do you
makes
have any
sense?
example? Yeah, do you have any examples of like F of F or G of G?
You can, yeah. I will show you another one, like F of F of 1. So same idea. F of 1 is 7. So I get now F of 7. Now I go to the 7. I find the F for the 7 is 5. So the answer is 5. Is it clear?
Yes. Thank you, Professor.
Same things for G. No problem. Professor, would you like please go again back to the F of the 4? This one? The one, this one? Okay. So F of 4, you go to the 4 here. Go to the 4. You find the F value for the 4. The F value means I'm using the Y value from the Y axis. The Y value for the F function. So this is 4. I'm not going to use the G function. The G function is the blue one. I have to find the Y value for the 4 for the F function. So the Y value is -3. You plug instead of F of 4, G of -3. Now you go to the G -3, the -3 I mean, then you have to find the G value for -3, the blue function. So the G value, I mean the Y value for the G, it shows here 2. So the answer is 2. Now for the second one, F of 7. You go to the 7, you find the Y value for the F of 7, or you find the F of 7. F of 7 is shows 0 because no value is 0. So F of 0. Now you go to the 0, you find the F value again for the 0. The F value for the 0 in the red function is 0. So the answer is 0. Make sense? Okay. Now let's go to the new section. This section is not in the exam, so it's 2.8. 2.8 is one-to-one function. One-to-one function. So what is the mean of one-to-one function? This is mean every element on the domain takes different element on the range. I will explain what does that mean. So suppose I have two diagrams. The first diagrams look like this. Yeah, I have 1, 2. Here I have 3, and I have 4. Here I have 20. Here I have theory. Here I have 60 and 70. 60, 70. And the other one is 1, 2, 3, 4. 1, 2, 3, 4. And here 10, 20, 30. 10, 20, 30. So this is function and this is other function. But this function, the element here, like the 1 goes to 30 and 2 goes to 20. The 3 goes to 60 and the 4 goes to 70. And for this one, 1 goes to 20, 2 goes to 3, for example, goes to 30, 2 goes to 10, and 4 goes to 20. Again, let's look. 1 here goes to 30, takes one element. The 2 goes to 20. The 3 goes to 60. And the 4 goes to 70. And here, 1 goes to 20. The 2 goes to 10. 3 goes to 30. And 4 goes to 20. As we look into the first function, every element in the domain, 1, 2, 3, 4, this is the domain, takes different element in the range. The 1 goes to the 30. 30 is different about 20. 20 is different about 60. 60 is different about 70. So every element in the domain takes different element in the range. So this is mean this function is 1-to-1. But here, the 1 goes to 20, 2 goes to 10, so 20 is different about 10, 10 is different about 30, but here the 4 goes to 20 again. So 1 goes to 20 and 4 goes to 20. This is mean the function is not 1-to-1 because the domain, the element in the domain does not take different element on the range. The 1 goes to 20 and the 4 goes to 20. This is mean not 1-to-1. It is a function, but it's not 1-to-1 function. So this function here is 1-to-1 function. This is a 1-to-1 function, but this is not 1-to-1 function. This is not 1-to-1 function. Why? Because the 1 goes to 20 and the 4 goes to 20. And this is make the function is not 1-to-1. Is it make sense how to think is the function is 1-to-1? So again, every element in the domain must be take different element in the range, as we look in this example. So this one is 1-to-1 is not, this one is not 1-to-1 because the 1 goes to 20 and the 4 goes to 20, and not every element in the domain take different element in the range. Or we can right now, to know the definition for the 1-to-1, we can check right now the function is 1-to-1 by two things. So to check, the function is 1-to-1 by two things. The first thing is by the definition. Definition of 1-to-1. The definition says if I have two functions, the first function f of x1, suppose f of x1 equal f of x2. Now we have to do some processes here to check is x1 equal x2. So if this things, then x1 equal x2. So I have to check x1 is equal to x2. I'm going to show that by the example. Second thing is to check the function is 1-to-1 by using the horizontal line test. Line test. Also, I'm going to explain that by the example, but let me give you the definition for the horizontal line test. It says if the horizontal line line can use different colors. If the horizontal line if I have a horizontal line and this horizontal line intersect the graph, only at one point. This means the graph is represent the graph represent the graph is represent a graph of 1-to-1 function. This is just definition to know what is the meaning of horizontal line test, but I'm going to explain that by the example below. So the example says, this is the most important. Which of the following are 1-to-1 functions by using the horizontal line test? So by using, I'm going to explain this by the, I will start by the horizontal line test. Give you the example for the horizontal line test. So by using the horizontal line test, check if the function, the graph is for 1-to-1 function. So the first one, the function f of x equal x cubed. The second one, the function g of x equal x squared. So I have two functions. The first function f of x equal x cubed. The second function g of x equal x squared. The question is, check by using the horizontal line test, is the function here is 1-to-1 or this one is 1-to-1? So let me do the first one, then I give you the second one. So for the first one, is f of x equal x cubed. So first things to check the function is 1-to-1, I have to graph the Cartesian, I have to graph the function. This is the first step. You have to graph the function. So the graph for this function, x cubed, as we learned before, it has a graph like this. This is the graph of f of x equal x cubed from previous sections. Now, to check this function is 1-to-1, I have to graph a horizontal line. Let me use different colors. Blue. This is my horizontal line. Then I have to check this horizontal line intersect the graph at only one point. So as we look into the graph, as we look into the line, it shows at every point the line intersect the graph at only one point. This is true. Look at this point, for example, intersect the graph at this point only. The line intersect the graph at this point only. Go up again, the line intersect the graph at this point is 0, 0. Again up, the line intersect the graph at this point only. So by using the horizontal line, it shows the line intersect the graph at only one point. So for example here, at only this point, the line intersect this graph. So this is mean the function f of x equal x cubed is 1-to-1 function. So by using the horizontal line test, the function f of x equal x cubed is 1-to-1 function. Any question? Any question for this example? How to check by using the horizontal line test? The graph is the function is 1-to-1. The graph of this function is 1-to-1. Okay, so for the second, for the second one, who will do the second one? The function g of x equal x squared. G of x equal x squared. How is the graph for this function, first of all? How is the graph for this function? U, this is true. So the graph has shape like this, U. Parabola, open upward. So this is the graph for g of x. Now, is the function 1-to-1 by using the horizontal line test? If I have a horizontal line like this is my horizontal line. Is this line intersect the graph at only one point? Is intersect the graph at only one point? No. So this is mean this function is not 1-to-1. Look, the line intersect the graph at this point and at this point. This means the function g of x equal x squared is not one-to-one function. So the function g of x equal x squared is not one-to-one function. Why? Because it fails by using the horizontal line test. The horizontal line test fail. Okay. Any question for this one?
Wait, so it fails the one-to-one test because it hits twice, right?
Because the line, the horizontal line, intersect the graph at 2 points. This is mean the function is not one-to-one. But for the previous one, the line, the horizontal line, the blue one, intersect the curve at only 1 point. This is mean one-to-one. Make sense? Is it clear?
Yes.
Okay. So if the line intersect the curve at only 1 point, this is mean one-to-one. At 2 points or more is not one-to-one. That's why the function f of x, g of x equal x squared is not one-to-one. Now, by using the definition, how to check this function is one-to-one by using the definition? Let me give you example, and I will explain by using the example how to check the function is not or is one-to-one by the definition. So the definition for the one-to-one is if f of x2, x1, sorry, equal f of x2, then must x1 equal x2, then x1 equal x2. If this condition does not achieve, this means the function is not one-to-one. Okay, let me give you example. By using the definition of one-to-one function, check or the question is show f of x equal 3x plus 4 is one-to-one function. So I'm going to do this one step by step. So the first step, you have to write f of x1 equal f of x2. So my function is f of x. So my function here, f of x equal 3x plus 4. Now you have to make sure to write down f of x1 equal f of x2. So it means, can we have like a review of the classes of any question? Yes, next time. Okay. So here to do this by using the definition of one-to-one function to show this function is one-to-one, I have to write down f of x1 equal f of x2. This means I have to plug x1 inside this function, x2 inside this function. Then I go step by step to check, is this one happen, x1 equal x2? So let me do here this one. So f of x1 here, when you plug x1 inside the function, I get 3 times x1 plus 4. This is equal x2, plug inside this function, I get 3 times x2 plus 4. Okay. Now we try to simplify this equation. So here I get 3x1 plus 4 equal 3x2 plus 4. Now I'm going to simplify this equation step by step. Here I have to subtract 4 from both sides. So now I get 3x1 equal 3x2. Divide both sides by 3. By 3. By 3. I get x1 equal x2. So this is mean if I arrive at this point, x1 equal x2, this means the function f of x equal 3x plus 4 is one-to-one function. So I can sit here. So the function f of x equal 3x plus 4 is one-to-one function. Why? Because I plug f of x1 equal f of x2, I do the processing until I get x1 equal x2. When I arrive at this point, this means the function is one-to-one. Any questions so far? Anyone has a question for this? No questions? Okay. So now let's go to the new things is the inverse of the function. So after we finish the one-to-one function and I explain how to find the function is one-to-one, now we can go over the inverse function. Okay. So the inverse function. So the inverse function, what is the meaning of it? What's the relationship between the inverse function and one-to-one function? The relation here, the function, if f is one-to-one function, if f is one-to-one function, this is mean I can find inverse for the function. So the one-to-one function is very important to find the inverse for the function. So the function must be one-to-one to find the inverse for the function. This is one of the questions that we will assign. So the function f must be 1-to-1. If it's 1-to-1, so I can find the inverse for the function. So if f is 1-to-1 function, the inverse function, the inverse function is defined as y equal f of x. So the inverse for these things, f inverse of y, I take the inverse for both sides, equal x. So if y equal f of x, I take the f inverse for both sides, f inverse of y equal f inverse f of x, and f inverse with the f is cancel each other, so I get x. So this is the relationship of the inverse. First things we have to know here, the domain of the function f, the domain of the function f is the same as the range of the inverse. And also the range of the function f is the same as the domain of the function f inverse, sorry. So vice versa, look, the domain, to find the domain of f, you can find the domain of f inverse, because the domain of, the domain for f is the same as the range of f inverse. And the range of f is the same as the domain of f inverse. I'm going to explain this by the example. So let me give you example, simple example. So the example now, suppose let we have f of 1 equal 5 and f of 3 equal 7 and f of 5, f of 8 equal 10. The question is, find f inverse of 5 f inverse of 10 and f inverse of 7. So what is f inverse of 5? What is the f inverse of 5? So by using this definition here, if f of x equal y, this is mean f inverse of y equal x. Same things here. f of 1 equal 5. So f inverse of 5 is the same as 1, same as inside the parentheses. Make sense? Same things, I'm using this here, this definition to find the example. F of 1 equal 5, but f inverse of 5 is the same as 1. So the answer for the first one is 1. What's the answer for the second one? F inverse of 10. Is 5, because f of 8 equal 10 is 5. How you find it? F inverse of 10. You mean 8, I think, right? F inverse f of 8 equal 10. So f inverse of 10 is equal this number, 8. From where I get it? From this one. From this one. Now for the last one, f inverse of 7. F of 3 equals 7. So f inverse of 7 is equal 3 exactly. How I know this? By using this definition. F of 1, this is f of 1, equal 5. Y is 5. F inverse of 5 is equal 1, the x value. Let me do this for the first one. Y, it's 1, equal f of, I mean, not y here. Y is 5, equal f of 1. Now, f inverse of 5 is the same as this one. And the same things for the second one and third one. So this one, I get from here. This one, find it from here. And this one, or this one. Any question? Okay. So now I'm going to give you graphs. And the question, find the f inverse from the graphs. This is a Wobble-Sign question. So the example now. Example. I get a question here. Is the rate of change and the slope are the same things? Who will answer this question? This is the x-axis. This is the y-axis. This is 1, 2, 3 here. One, 2, 3. The value for 1 is 25. The value for 2 is 20. The value for 3 is like around here, like 30. The question is find f inverse of 30 and f inverse of 25 and f inverse of 20. So to find the f inverse of 30, you have to go to the 30 in the y-axis, this value. Then you have to draw a horizontal line. This graph is not 1 to 1. Let me change it. Because to find the inverse, we have to get a function is 1 to 1. So this is my function. This function, the graph is 1 to 1. Why? Because it's passing in the horizontal line test. So at 30, to find the f inverse of 30, you have to draw a point like this, and you see where is this point? What's the x value for this value? I mean, like to have to draw a horizontal line at 30 like this, and you see you have to check what is the value for the x for this function. It's look like here, like around 2 point something, like 2.2, for example. So the answer is 2.2. Same things for f inverse of 25. You go to 25, draw a horizontal line, intersect the curve at this point, and then you have to find the x value for these things. The x value like around here. So it's like around 1.5. This makes sense? Now, what's the f inverse of 20? Something like this. Go down. It's like around 1. Yes, thank you. Okay. Any question for this example? Any question for this one? Yes, Chris, do you have a question? How to find the inverse?
No.
Okay. Now, okay, let me give you another example. No, I'm going to give you only the last things is the cancellation properties. And after the cancellation property, I'm going, so you can go to the over the website for the quiz, okay? So the cancellation property says, here, cancellation. So let the function 1-to-1, let f be 1-to-1 function. And let f inverse be the inverse function. Be the inverse function of f. So then you have to know f circle f inverse of x is equal x, and also f inverse circle f of x is equal x. If this one and this one, number 2, satisfy, this means the function f and this one f inverse are inverse to each other. I'm going to use different like variables. Let me use here g instead of f. This is g. F be 1-to-1 function, and let g be the inverse function of f. Then f circle g here f circle g of x and g circle f of x equal x. This means from 1 and 2, this means the function f and g are inverse to each other. Okay. So I'm going to stop up to here today and get ready for the quiz. Go to the website. Okay. Any question before we stop this lecture?
How much time do we have for the quiz?
15 minutes.
Okay.
Any question for
will
the
will it be
cancellation
like-
property?
Sorry, will it be like last time where we have one question and then we click on next?
You have to submit the answer before the time is finished.
Oh,
Okay.
okay.
make sure you submit the answer before the time is finished. So I'm going to stop the lecture up to here today and get ready for the quiz. See you next time.